In this video, I'm going to explain how to write basic smart contracts with Sway, as well as how to write basic Rust tests along with it. To begin with, you're going to need to install Fork as well as Fuel Core. If you don't have, if you're using Windows, then you're going to need to use Windows Subsystem for Linux, since Fork does not currently work on Windows. So to begin, there are 4 types of Sway programs: contracts, predicates, scripts, and libraries. Libraries are reusable code such as the standard library, which could be imported into your contract file. Contracts are like the basic contract or that you would write in Solidity. Predicates are kind of like Bitcoin scripts, if you are familiar with that. It is not really necessary to know them for contract development. And scripts are what you would use to actually call the contracts from an end user address. To initialize a project, you just type fork new and then the name of the project. So over here, I'll just go. Let me delete this first. Let's type fork new and then counter. It will create this folder which will have the source file, which contains the main Sway file, and here it will also generate a tests folder which contains the Rust test harness. So we are going to make a counter project which will have a storage variable which has a count u64 type, and we will have a function that will increment the count every time we call the function. We will also have a function to return the current count in this contract. So let's look at the anatomy of a Sway contract. Over here you can see there is contract semicolon, an ABI, and then an implementation of the ABI. So the first line, contract, signifies the type of Sway program this file is generating. So as we saw earlier, there are 4 types of Sway programs. So here you could either have contract, script, predicate, or library, and then the name of the library. Currently we are just making a contract, so it would be just contract. The next part is the ABI. Here we are describing a contract with external functions. So this my contract ABI has one test function which returns a boolean. There is no implementation of the actual function, as this is just a interface. It is not the actual contract. Other contracts could import this ABI and then use it to call your contract. The next part is the actual implementation of the ABI for the contract. Over here, this contract is a keyword. It is not a name of a type, unlike my contract. Over here you actually implement the test function or any other functions in the ABI, and yeah, here it is just returning a true type, a true value. In our contract we will have a little more implementation. There's also a storage keyword you can have to have storage variables. Let me make one. This allows you to have a variable, here count, which is of type u64, initialized at a value of 0. This storage variable will persist across contract calls. If you had a local variable in this test function, like let x equals 0, if you change the value of x in one function call, in the next function call it would be back at 0. That's why if you want persisting storage data, you would use a storage variable. In Sway there is no constructor, so you need to initialize the variable directly with a equals to sign. In Sway the syntax is very similar to Rust. Sway is a strongly typed language, so this counter variable would have a u64 type annotation with the colon in between. There are no null or exceptions in Sway. Variables are immutable by default except the storage variables, the one I just defined here. And the syntax for a function is fn, which stands for function, then the name of the function, and in brackets, like if you had one argument, it will be like argument a, and then colon, and then the type of the argument, and then this dash and then smaller than sign, which would be signifying the return value, and then you would just have the return type. There is also something called a storage attribute, which you would put above or before the function signature. This basically tells the compiler what the function is doing. If it is reading and writing to storage, then you would have both read and write. If it is only reading, then you would have storage only read, no write, and of course the same for write. This allows the compiler to make some optimizations during compile time, and it also provides some safety guarantees. To access storage in a function, you would do storage dot and then the name of the storage variable. There is also an implicit return in Sway, which you can just do by not having a semicolon in a statement. So let's make a counter contract. So let's remove this current function. We will take no inputs here, we don't really need anything, and we'll return a u64. And we'll also have a function set get, which will get the current value. And here, since we are going to read the current value and then increase it, so we'll need both read and write. Over here we are only going to read, so we can have just read. So over here, by not having a semicolon at the end of this line, I am implicitly returning storage.count, which is of type u64, which is what I'm returning over here. So what this does is it takes storage.count plus equals is shorthand for storage.count equals storage.count plus 1. So this would be equivalent to storage.count equals storage.count plus 1, and then I just return the current value, which would be on the first function call, it would return 1. And we can also have a get function, which just returns the current value. So let's compare, is it the same? Yep. Let's see if it compiles. Fork. Oh, oops, there should be a semicolon here. In the API, whenever you have a function signature, you end it with a semicolon, and in the storage you end it with a comma. So it looks like this compiled now. We can begin writing a test for it. So over here in the harness.rs, it already has some boilerplate code. You need to have fuel core installed in order to run a local node, which will allow us to run the tests. You need to use the Rust nightly toolchain in order to compile this Rust test. So the command for that, like to change your Rust toolchain, would be to do rust up install and then nightly. I have already done that, so I'll just show you how it's done. Yeah, I have already changed my toolchain to nightly, so it didn't do anything, but for you it should compile something, so it would take a while. So this is the test we're going to write. In this get contract instance, it returns my contract. That's the name of the name of our API over here, my contract. So it just returns an instance of that API. What we can do is take that instance and then just call any API function on it. So over here the name of the function is increment, so we can just do function dot increment and then dot call dot await dot unwrap, and then since it's returning a value, we can do dot value and then store the result in a result variable. Over here what's happening is this instance variable is an instance of our contract which this function returns. You don't really need to look at this code, it's boilerplate. And we call the increment function on this instance of our contract, and we do this dot call to actually call it, and then since it's a asynchronous function, we do dot await, and since there's some chance that it could fail, we do dot unwrap, and then since it's returning a like it's returning a u64, we have to do dot value in order to get the return value. Let's also do instance dot get. So we can write a assert equal what this assert equal macro does is it makes sure that the two variables that you input here are equivalent to each other. So over here we incremented, so it should return 1, and then over here since we already incremented it, it should also return 1. So let's make sure that is actually 1, and since we're already checking that these two are the same, we don't need to repeat it for val. And to just make sure that it's actually doing something, we can repeat the entire code and have it be 2 instead of 1. Let's see if this compiles. You do fork test to run the test. It should take a while for it to compile since I'm doing it for the first time, but after the first time it's usually much faster. Looks like the compilation is done. If you don't want to wait this long for every time for compiling the Rust tests, you can also use the TypeScript SDK. Although the TypeScript SDK is mostly meant for writing UIs and the Rust SDK is mostly recommended for writing tests. But if you don't feel comfortable writing Rust, you can always use TypeScript. It says running one test, which is this one test, and it says test can increment OK. That means the test passed. So there were no issues and these assert equal macros passed. If you want to make a separate test, you can just do Tokyo double colon test and then make a async function with any name you want. No inputs, and then just do let instance equal get contract instance dot await, and then you can call any function in the contract with instance dot and then the name of the function like increment, and then if you want to, you can have the return value be saved to a result like that, like over here. But right now over here we only need this one test since the functionality for our contract is very limited. Anyway, that's the Sway contract as well as the Rust testing finished for this counter contract.